Hello everyone, welcome to Math Core. This is the video that I mentioned I may or may not do, which if you're watching this, I did it. What we're doing in this video is we're looking at a very specific textbook, an online textbook from OpenStax. This here is the textbook in question, College Algebra by OpenStax. And there's other ones too. There's pre-algebra, trigonometry, calculus. This specific textbook, I don't know the actual author. It says J. Abramson of the Arizona State University. So he is the senior contributing author. So yeah, I guess he would be the author, the main author. So this textbook has been made free for anybody. You can go on a website or wherever. I got mine off the Amazon Kindle app. I'm sure you can get it off the official website, I suppose. So these textbooks, they are open source, free to use, and they're just great work aids for learning many of the different branches of mathematics. So what we've been looking at, it won't let me click. We've been working in prerequisites, so like pre-algebra level stuff. And I have, let me see. So we are going to be working with section 1.5. I'm not going to do the verbal stuff right here. What we're going to work on is the algebraic stuff, these right here. We're going to do these problems. So you can download the book and follow along. It won't let me click out of it. That's weird. Anyway, and there's more questions. So I know for sure we're going to work through 4 through 50. At least I'm going to try. I haven't worked through these problems, so I don't know how tricky a lot of them are. Why does this do that? If you know how to stop this, let me know in the comments. I don't like this. It's aggravating, and it don't go away. There's other problems. There's real-world applications, and extensions, I suppose, are more difficult problems. But considering that we have some wild numbers, 90, 181, 90, considering we got some crazy numbers here, I'm sure these are going to be difficult enough and intuitive enough that we can really cement this idea of factoring into our minds. Alright, so without further ado, we are going to begin with number 4. Find the GCF. Now, number 4. 14x plus 4xy minus 18xy squared. First and foremost, I see we have, let me get my highlighter. I see we have an x in each term. So we can factor out the x. And all these terms are also divisible by 2. So we can factor out a 2. So let's go ahead and use a green color. So we can factor out 2x. And that'll leave us with 7 plus 2y minus 9y squared. And if you wanted to, you can rewrite this as negative 2x times 9y squared minus 2y minus 7 if you wanted to have the square in front. Number 5. I don't know why I put that backwards. 49mb squared minus 35m squared ba, got 3 variables, plus 77 MA squared. I forgot to mention, I probably will not write subtitles into this video because it's not a scripted video. I'm doing this, I am recording this without really following any kind of script at all. So I probably, to get this out more quickly, I won't have subtitles. Okay. Now looking at the variables, we can pull out an m. Why did that jump? We can pull out an m, but no b's because there's no b here, and no a's because there's no a here. So just the m. And let's see, 49, 35, 77. What can we pull out of here? Looks like we can pull a 7 out of here. So we could go ahead and factor out 7m times 7b squared minus 5mba plus 11a squared. Number 6. 30x, that's supposed to be a cube, 30x cubed y minus 45x squared y squared plus 135 xy cubed. So does any of this divide by 3? 45, we know we can do 15, 30, 45. So we know we can factor out a 3 from this term. What about this 135? Well, we could factor 50 out of 150 3 times. So if you minus 15 out of that, that's 5, 10, 15. We could factor out a 45 out of it. So yeah, we could factor out a 3. This would give us 3. Do we have xy, xy, xy? Go factor out x and a y. This leaves us with x squared minus 15xy plus 45y squared. These numbers really are all over the place. Number 7, 200 p cubed m cubed minus 30 p squared m cubed plus 40 m cubed. All right. Well, we can definitely factor out a 10 and an m cubed. Let's see what that looks like. 10m cubed. This gives us 20 p cubed minus 3 p squared plus 4 no m. That's it. And we cannot pull anything else out. You might wonder, well, we got all even numbers here, so we can definitely pull a 2. And then you might find, okay, you can now you can pull a 5 out, and then you'll get to this correct answer right here. It's no problem starting with smaller factors to work your way up. Sometimes it's easier that way, which I think we may have to do it like that if these numbers keep getting big like this. Number 8, we have 36 j to the 4th power, wow, okay, to the squared minus 18 j cubed times k cubed plus 54 j squared times k to the 4th. Seeing j's and k's right here kind of throws me off a little bit. There's a subject in calculus where j's and k's, more specifically i's, j's, and k's, have a very specific meaning. So let's see. What can we pull out of this? I immediately see 9. We can pull a 9 out of this. So we have 9. What variables? We can pull out a j squared and a k squared. J squared, k squared. This leaves us with 4j squared minus 2jk, just kidding, plus 6k squared. And we can pull out something else. Notice I got a 4, a 2, and a 6. So we can keep going. Let's pull out the 2. This gives us 18j squared k squared times 2j squared minus jk plus 3k squared. That's an example. I didn't plan that. So what I mentioned from right here, sometimes you can pull out smaller numbers. You could pull out the 2 first and then the 5 and to get to this answer. Or just like right here, we pulled out the 9 first and then we saw that we can go again by pulling out the 2. All right, number 9. 6y to the 4th power minus 2y cubed plus 3y squared minus 1. This one has 4 terms. So we can't pull any any coefficients out because there's 1 right here. Or we could factor out, it's kind of strange. I wonder why this question, I feel like number 9 should be in the next section, but we'll go ahead and do it anyway. So we can use let's use grouping. So we're going to factor out a 2y cubed. That leaves us with 3y minus 1. And if we factor out a 1 right here, this leaves us as 3y. I miswrote the problem. That's supposed to be a y, not a 1. That's why that's why I'm messing up. Okay. We factor out the y right here. This leaves us with 3y minus 1, which gives us 3y minus 1 times 2y cubed plus y. And the reason why I thought that strange is because this is the last question on this section. The next section, numbers 10 through 15, ask us to factor by grouping. So I'm going to go ahead and erase all this, and we'll get started on that next. Okay, number 10, factor by grouping. We have 6x squared plus 5x minus 4. Go ahead and use a different color. Let's go to blue now. So we need to find factors of negative 24 that add up to 5. So let's see, factors of 24. Does 2 and 12 give us 5? No. Does, let me think, 3 and 8, can 3 and 8 give us 5? Yes, if the 3 is negative. And notice how we have a negative 24. That makes it perfect because one of our terms is going to be negative. And since this middle sum is a positive sum, we know a smaller term will be the negative term. So we can rewrite this as 6x squared minus 3x plus 8x minus 4. Now we can factor by grouping. Let's factor out the 3x from the first part. This leaves us with 2x minus 1. And we can factor out the positive 4 right here. And this will leave us with 2x minus 1. Our terms match. We have 2x minus 1. That does not look like a 2. Times negative 3x plus 4. Number 11. We have 2a squared minus 9a. That's a plus. Why did I say minus? Plus 9a minus 18. On the side note, you'll find why this is why I like scripts so much, because I don't make as many mistakes. When I'm talking without a script, I say lots of goofy stuff. Okay, we need factors of negative 36 that add up to 9. So we have a negative factor. That means one of our terms is going to be negative, but a sum is positive, so the smaller term is going to be negative. Okay, 9 and 2 will not give us 9. How about 3 and 12? 3 and 12 will give us 9. So we have 2a squared minus 3a plus 12a minus 18. We can leave these two variable of coefficients there and just factor out the a. This gives us 2a minus 3. And if we factor out, let's see, a positive 6 right here, we get 2a minus 3. Our terms match, so our factored polynomial is 2a minus 3 times a plus 6. Number 12. 6c, that does not look like a c. 6c squared, that still don't look like a c, plus 41c plus 63. Okay, so now these terms are going to get bigger. We need factors of, let's see, 63 times 6. We need factors of 378 that add up to 41. Okay, we need a calculator. Nothing wrong with calculators. Okay, let's see. 378 divided by 2 will not give us 41. Okay, 378 divided by 3 will not give us 41. 378 divided by, that's a minus, I meant to say, divided by 4 does not give us 41. 378 divided by 5, obviously not. 378 divided by 6. 63 and 6 does not give us 41. I should state, since our product or our factors are going to be positive, or sum is going to be positive, therefore all of our terms are going to be positive. We're not going to deal with any negative terms. So 378 divided by what I left off, 6. How about 7? 54 and 7. No, we need something less than 41. So let's see. That was 7. Let's do 8. No. 9. 42, and that's close. How about 10? Obviously not. How about 11? That's definitely a fun number. How about 12? Nope. 13? Nope. 14. Here we go. How about this? 378 divided by 14 gives us 27. 27 plus 41 plus 14 does in fact give us 41. That is the term we need. Or the terms we need, I should say. So we have 6c, let me use my blue marker. We have 6c squared plus 14c plus, what was it? 27? Yes, 27c plus 63. Okay, fact about grouping, we can't pull a 6 out. 14, we could pull a 7, no, 2. Looks like we can only pull a 2 out, so that gives us 2c. This gives us 3c plus 7. Can we get 3c plus 7 out of here? I believe we can if we pull out a 9 plus 9. That gives us 3c plus 7. Our terms obviously match. We have 3c plus 7 times 2c plus 9. Now, like I said, I have no problem using calculator because if we did all that scratch work looking for those factors of 378, that would have took up this whole screen. We don't want to waste that kind of time doing this. We know arithmetic. Now we're trying to now we're trying to prep ourselves for algebra. Number 13, 6n squared minus 19n minus 11. So we need terms of negative 66. That give us negative 19. So the larger number is going to be negative, and the smaller number is going to be positive. Factors of 66. 2 and negative 33 will not do it. How about 3 and negative 22? I believe we have a winner. So we can rewrite our polynomial as 6n squared plus 3n minus 22n minus 11. Factor by grouping, we factor out 3n. This leaves us with 2n plus 1. Let's factor out negative 11. This leaves us with 2n plus 1. So therefore, our polynomial is 2n plus 1 times 3n minus 11. Erase the board, and now get ready for the next. Number 14, 20w squared minus 47w plus 24. So we need factors, big numbers. So we need factors, let's see, 20 times 24, that's 0.8004. So we need 480. Okay, factors of 480. Let's pull out the calculator. Okay, 480. We really need small numbers. Now note that the product is positive, but the sum is negative. That means both of our terms are going to be negative. That means we need two small numbers. So let's see, let's go to 10. Oops. Let's start with 10, huh? Hey, that's pretty close. How about 480 divided by 15? Hey, second try. That's pretty cool, right? Okay, so we can rewrite our equation as 20w squared. I forgot it that fast. Can it pull up? Thank you. 15 and 32. Okay, minus 15. What kind of 5 is that? W minus 32w plus 24. Now we can factor by grouping. Let's see. I will pull out a 5w. This will leave us with 4w minus 3. Can we get the same thing out of here? Yes, if we pull out a negative 8, this will leave us with 4w plus, oops, no, minus, it's supposed to be minus 3. Therefore, our factored polynomial is 4w minus 3 times 5w minus 8. Number 15, 2p squared minus 5p minus 7. Okay, this one for the last one here seems a little easier. So we need factors of negative 14 that add up to negative 5. So the larger number is going to be negative. I can already tell you it's going to be 2 and negative 7. So we got 2p squared plus 2p minus 7p minus 7. Oh, that's easy, right? 2p times p plus 1 minus 7p plus 1. This leaves us with p plus 1 times 2p minus 7. Yeah, so these are kind of going backwards from the format that I taught. I believe I did factor by grouping after special cases, but this seems to be using special cases after grouping. But that's neither here nor there. Let's go ahead and erase the board. Okay, now we are going to factor the polynomial for numbers 16 through 36. That's the big chunk of the exercises right here. Okay, right to right. Number 16 is simply factor the polynomial. We are not given any rules. We can do whichever rule we decide. So that means we need to pay attention at what's being asked of us. So number 16, 7x squared plus 48x minus 7. I immediately do not see any rules we could follow. So let's go ahead and factor by grouping. So we need factors. Oh, I see this already. We need factors of negative 49 that give us 48. I say 49 and negative 1. So 7x squared minus 49x. That's plus. Oh man, I messed that up. Okay. That's positive 49 minus 1 minus 1x minus 7. I messed that all up. Okay, let's go ahead and factor out our grouping. 7x. This leaves us with x plus 7 minus 1. X plus 7 equals x plus 7 times x minus 7. I'm sorry, x minus 1. So many mistakes. Okay, number 17. 10h squared minus 9h minus 9. Let's go ahead and find our factors for negative 90 that sum up to negative 9. So 1 and 90 won't do it. It's 1 and 90, no. 2 and 45, no. 3 and 30, no. Let's just go ahead and pull out the calculator. How about 90 divided by 4? No. 90 divided by 5? No. 90 divided by 6? That looks like it. 6 and 15. So we got 10h squared plus 6h minus 15h minus 9. Go ahead and factor by grouping. We get 2h times 5h plus 3 minus 3 times 5h minus plus 3. This leaves us with 5h plus 3 times 2h minus 3. Number 18. 2b squared minus 25b minus 247. Big numbers again. Pull out your calculator. 247 times 2. So we need factors of 494 that sum up to 25. Our product is negative. That means one positive and one negative term. Our sum is negative. That means our term is going to have a larger negative term. Or our set is going to have a larger negative term. Alright, so 494 divided by 2. This might take a while. Okay. So I found 494 divided by 13 gives us 38. So if we go ahead and rewrite our polynomial as 2b squared plus 13b minus 38b minus 247. Make sure I got the right numbers again. 13 and 38. Yes. Okay. So if we go ahead and factor by grouping, we get b times 2b plus 13. So to get this to 2, we need 19. So if you factor out negative 19, this leaves us 2b plus 13. And we could finally factor as 2b plus 13 times b minus 19. Number 19. 9d squared minus 73 plus 8. 73d plus 8. These big numbers are so wild. Okay. So we need terms of 72 that sum up to 73. 9d squared minus 72d minus 1d plus 8. That was a super easy one, right? Okay, so we go ahead and factor out 9d. This leaves us with d minus 8 minus 1 times d minus 8, which we write our factor polynomial as d minus 8 times 9d minus 1. Number 20, 90v squared minus 181v plus 90. Oh my, okay. So we need factors of, oh my god. I should have did that in my head, but I don't know why I didn't see that in my head. It's such a big number to find. Oh my word. And it has to add up to negative 181. Okay, so because our product is positive and the sum is negative, both of the numbers are going to be negative. That means they're going to be two smaller numbers less than 181. And the sum of those two numbers add up to 181. Okay. How about 8100 divided by 100? Check that out. First try. 181. So we got 90v squared minus 100v minus 81v plus 90. Okay, I see the logic in that. Okay. Slick. 100 is the... yeah. Okay. That's cool, right? Because like 100 is divisible by 90. And 81 is divisible by 9. I don't know. No, that's my head working in weird ways. Excuse me. So, okay, let's go ahead and factor out. Start with 10v, right? 9 minus 10, 9v minus 10. And if you want to get the same thing here, minus 9. 9v minus 10. This leaves us with 9v minus 10 times 10v minus 9. Yeah, that's kind of cool. Okay, that's neat. That's so if we swap these two, we get a number that's both just like with the same term in the first and third term, but with the square, or how would you look at that? Times 10 and times 9. It's interesting. It's an interesting concept. Okay, moving on. 21. 12t squared plus t minus 13. Okay, so we need factors of, let's see, 12 negative 156. Now, if you notice that this is a funny polynomial. Notice that both 12 and negative 13 multiplied together give us negative 156. But these same numbers, when you add up together, gives you negative 1. So if we swap the signs, if we have negative 12 and 13, my horrible handwriting. Check that out. That's pretty cool, right? 2t squared, squared, minus 12t plus 13t minus 13. Oh, that's so easy. 12t, 1 minus t minus 1 plus 13t minus 1. This gives us t minus 1 times 12t plus 13. 22. 2n squared minus n minus 15. My handwriting is getting so funky. I need to write slower. Okay, so we need factors of negative 30 that sum up to negative 1. 2 and 15 will not do it. 3 and 10 will not do it. 5 and 6 will actually do it though. So let's go ahead and write it out as that. 2n squared. That's going to be a negative 6 plus 5n minus 6n minus 15. N times 2, n plus 5 minus 3, 2n plus 5. This leaves us with 2n plus 5 times n minus 3. Number 23. 16x squared minus 100. Here we go. Now we're talking. We have right here a special rule. This is a difference of squares. We could also rewrite this as 4x squared minus 10 squared, right? And we know that this is going to give us a plus b, a minus b, right? So we can just go ahead and simply write this as 4x plus 10 times 4x minus 10. Love it when problems work out so easy like that. Okay, 24. 25y squared minus 196. We can go ahead and rewrite this as 5y squared minus 14 squared. And this will give us 5y plus 14 times 5y minus 14. So cool. 25. 121p squared minus 169. We go ahead and rewrite this as 11p squared minus 13 squared. So this will factor out to 11p plus 13 times 11p minus 13. 26. 4m squared minus 9. Do you still feel the need to write these out as squares? If not, you can just write 2m plus 3 times 2m minus 3. I still wrote a 9 anyway. 3. Okay. Super easy, right? 27. Let's see how difficult they get. Boy, do they get difficult. 361. I promise you, I did not look at this problem beforehand. Minus 81. 261d squared minus 81. Let's just go ahead and find out what the square root of 361 is. Oh, here we go. 361. Wait, how do you do that? 361. You gotta do that first. Ah, okay, 19. So 19 squared. Okay, cool. Can't memorize them all, right? 19d squared minus 9 squared. This factors out as 19d plus 9 times 19d minus 9. 28. Why did I write that question in yellow? That's interesting. Number 28. 300. Oh, I wrote a 2. 324x squared. Still so big. Okay, minus 121. So go ahead and write 324 squared. That's going to be 18. So we got 18. Go ahead and make that yellow. 18x squared minus 11 squared. And this factors out as 18x plus 11 times 18x minus 11. I wrote an 18. 29. 144 b squared minus 25c squared. I recognize this immediately. I'm going to go ahead and write it out first. 12b squared minus 5c squared. And this factors out as 12b plus 5c times 12b minus 5c. Number 30, we're getting through them. 16a squared minus 8a plus 1. Okay, now we get into something called perfect square trinomials. How do I know it's a perfect square trinomial? Because both the a term, or the first term, and the third term are perfect squares. And the middle term is the product of the roots times 2. 4 times 1 is 4 times 2 is 8. So we know it's a perfect square. Remember the formula. X squared plus 2xy plus y squared, right? Okay. And do you remember what they factor into? They factor into x plus y squared. Go ahead and erase that. So we know x can be written as 4a squared minus 8a plus y squared. So this will factor out as 4a minus 1 squared. Seems strange, doesn't it? Let's go ahead and use FOIL and just see that it does go back just once. I haven't been doing that, but we can go ahead and do that. It's 16a squared minus 4a minus 4a plus 1, which gives us 16a squared minus 8a plus 1. So we can see it does give us the original answer. So we know it's the right thing. Sometimes it just helps to actually go back and see that it does work, which is pretty neat. 31. 49n squared plus 168n plus 144. Let's go ahead and rewrite this with our perfect squares. 7n squared plus 168 plus 12 squared. And therefore, our factored binomial is 7n plus 12 squared. Make that more like a 7, huh? 32. 121x squared minus 88x plus 16. Let's go ahead and write our perfect squares. 11x squared minus 88x plus 4 squared. This factors out as 11x minus 4 squared. And we can immediately see 11 times negative 4 times 11 will give us negative 44 minus 44, which gives us negative 88. So you can see in the head, if you do the math in your head, you can see that this is the right answer, which is pretty cool. 33. 225y squared plus 120y plus 16. 225. I used to get this messed up all the time with 25. I used to think the square root of 225 was 25. The square root of 225 is actually 15y squared plus 120y plus 4 squared. I used to always mess that up for some reason. I don't know why. I guess because that 25 there. So don't let that 25 tip you over. This factors as 15y plus 4 squared. 34 m squared minus 20m plus 100. Don't let this first term fool you by not having a coefficient in front of it, because it's still a perfect square. M squared minus 20m plus 10 squared. Don't let that fool you. This factors as m minus 10 squared. 35. 25p squared minus 120p plus 144. Once again, I wrote that in yellow for some reason. This fact, we can find our perfect roots as 5p squared minus 120p plus 12 squared. Therefore, our perfect square trinomial factors as 5p minus 12 squared. That's it for that section. That we did the 1, 2, 3. Now we have the fourth section, which algebraic for the algebraic problems. This fourth section is the final section, but weirdly enough, it contains the same instructions for the following exercises. Back to the polynomials. Not sure why they split that into multiple sections. Maybe these are a little difficult. And looking at them, yeah, they are a bit more difficult. I think we can do them. Ooh, those last ones. Those might be a little rough. A lot of algebraic work. Let's see what happens when we get to them. Number 37. So this is numbers. I erased my last numbers. 37 through 50. It means 13 more problems. Home stretch. Once again, I'm using yellow. X cubed plus 216. Do you remember what we should do with these? I believe it was the last lesson we did on polynomials. Remember the acronym. Let me write it up here. Over here. SOAP. Same, opposite, always positive. We're going to need that for sums and differences of cubes. Go ahead and use a new color. How about red? So we're going to factor this as x plus, what is the cube root of 216? To be honest, I don't know myself. Can we do it like this? No. How do you do cube roots on this thing? I have to admit, I don't use this Windows calculator. Never did. I have one of those really fancy ones, the TI Inspire one, and I find it so intuitive to use that. I don't even see the caret symbol. It's gotta be up here somewhere, huh? Oh wait, no, I thought I saw it. I didn't. Second one. Okay. It still doesn't give me the caret term, which we're gonna have a little problem once we get to numbers 44 and on, because those are going to have rational exponents. Yep, polynomials with rational exponents. I didn't cover that in my lessons. Maybe I should have put one or two of those in there. But we're gonna cover them now. If I can figure out how to do a caret symbol. Let me go and download a better calculator than this. I'll be right back. Alright, I'm back and I've got this crazy looking monster of a calculator. Check this thing out. I found this on the Windows Marketplace, or Microsoft Store, I guess it's called. And the title of it is called Calculator Squared. Interesting, right? And it doesn't have exactly well, it does have it. So normally, let me show you. Where's my pen? Normally on the calculator, you would see like a caret symbol. And if you push that caret symbol, say if we had 2, you push a caret symbol and you push 5, it's equivalent to saying 2 to the 5th power, which equals 32. But this calculator doesn't have that. But it does have this thing, x to the n, which acts the same way. And when you type it, so if I type 2, x to the n, there's that caret symbol. See that little arrow? That's the caret symbol I've been looking for. 2 to the 5th power gives us 32. So we can use that. So if I type, say, for example, 8 to the, let's try a root. 1 over, wait, I might actually have to use parentheses for that. Let's backspace. What? It's delete? Okay, interesting. 8 to the parentheses 1 over 3, close parentheses, which give us 2. Cube root over 8 is 2. So it's not as intuitive as I would like it, but for now, until I figure out what's a good calculator to use, I'll be honest with you, I don't have good knowledge on computer calculators. Like I said, I've used physical calculators all my life. Okay, with that said, let me go ahead and erase all this. And we're all looking for the cube root of 216. So let's get back on track. Clear. We need cube root of 216, which is 6. So 6 cubed is 216. Okay. So we have x plus 6 times x squared minus 6x plus 36. Do you remember the formula? It was x plus y times x squared minus xy plus y squared. Same, opposite, always positive. So always remember not to get these signs mixed up. You want to remember where each sign goes. So number 38. We have 27y cubed minus 8. Let's go ahead and rewrite this as 3y cubed minus 2 cubed. Must be a 3. Okay. So this factors as 3y, same, opposite, always positive. So minus 2 times 9y squared plus 6y plus 4. Remember, x minus y, x squared plus xy plus y squared. Same, opposite, always positive. It's a little tricky, and to be honest, this equation does look kind of, this expression does look kind of funky. It really does. But it works. Notice how that's a good point. Oh, wow, look at this. Okay. Notice how these two terms have 3y as their factor. But these two terms have 2 as their common GCF, greatest common factor. Let's go back to the first one, the number 37. Notice how these two terms have x as their greatest common factor. And notice how these two terms have 6 as their greatest common factor. That's a hint to seeing how all these numbers relate to each other. It's always great to look for relations between numbers, because when you want to move forward in math is nothing but relations, especially in calculus. All right, number 39. I'm getting over ahead of myself. I'm getting excited about that. 39. Okay. 125 a cubed plus 343. Now, I'll be honest. I know what 125 cubed is. That is 5a cubed. But I don't know what 343 is. So let's see. Clear. 343. 7. I think I remember that. So 7 cubed. So it's positive. So it's going to be positive, negative, positive. So we got 5a plus 7 times 25a squared minus 35a plus 49. Let's look again. 25a squared and 35a each have 5a is a greatest common factor. And 49 and 35a have 7 as their greatest common factor. Look how cool that is. That's so great. 40. b cubed minus 8d cubed. Not sure what I was trying to write right there. Okay, so let's go ahead and rewrite as b cubed minus 2b cubed. And then our factored polynomial is b minus 2b. D, that's supposed to be D, not B. Wow. Pay attention, because if you end up like me, you're going to struggle. So always pay attention. Okay, so we got B minus 2D times B squared plus 2B times D plus 4D squared. That's trick variables. They tricky. Okay, number 41. 64 x cubed minus 125. This one should be easy. We have 4x cubed minus 5 cubed. Kind of strange that they went from 2 variables back to 1 variable, but whatever. 4x minus 5 times 16x squared minus 20, positive 20x plus 25. Super easy, yeah? Barely much to talk about. 42. Wrote that backwards. Holy moly. Now look what we got here. 729 Q. I love the letter Q. Don't know why. Cubed. Plus 1,331. I'm fairly certain that 1331 is 11 cubed. Fairly certain. Yeah. But what about 720? What do you think that is? I'd say 7 cubed. No. 9 cubed. Oops. It's 9 cubed. Second choice. So we got 9 cubed. Be careful with that. Might want to put a hook right there so you don't mix those two up and end up writing 99 plus 11 cubed. And we could write this factors out as 9q plus 11 times 81q squared minus 99q plus 121. That is some funky numbers, right? But once again, notice how these two terms have 9q as a greatest common factor. And the second set of terms has 11 as a greatest common factor. I'm going to keep bringing that up because it's really cool to recognize these patterns. 43. 125 r squared, or cubed, I'm sorry. Rewrite that. Cubed plus 1,728 s cubed. Be honest, I don't know what that is. I know the first one. I know this is 5r cubed. I have the slightest idea for the second term though. 1728, 12. 12 cubed. It's 12 cubed. Yeah, 12 cubed is 1728. So we could write a factor of this sum of cubes as 5r plus 12 times 25r squared minus 48r plus 144. Oh, I'm going to erase right now because we got something else coming up. These, I did not cover these in my lessons with y'all because the books I was reading. So I didn't mention that. When I study, I have several different books I like to study from. One of my favorite authors is Ron Lawson. And a lot of people don't like Ron Lawson because his books are simplistic or whatever, you know. Some people have opinions, but if you look in the example section, there's hundreds, literally hundreds of examples. See right here, we've got 50. In his books, you're going to have like 150 of these. It's crazy. Lots and lots of practice. And I love that. And if I remember correctly, I didn't see these in his books. And I also have Hoffman, some others, Heal and with a combination of authors. I forget their names. I got so many that I study off of. But I think I think I've seen, so in these particular, I believe I've seen these type of what I'm trying to say is I believe I've seen these type of equations in pre-calculus books rather than just algebra books. Maybe some of them have them, but you're going to see what I'm talking about right now. Number 44. We have 4x times x minus 1 to the negative 2 over 3 power plus 3 times x minus 1 to the 1/3 power. You're probably thinking, what in the world are we looking at? And I wouldn't blame you. I'd say the same thing. Let's use a new marker. Let's go to orange. How do we do this? Well, first of all, we need to find the greatest common factor. That's what we're doing. That's how we factor. So I can point right now. I see greatest common factor. X minus 1 to the negative 2/3 power. X minus 1 to the 1/3 power. I'm going to show you how to do this. So we're going to factor out the GCF that contains the lowest variable. The lowest variable is negative 2/3. It's not 1/3, negative 2/3. So let's go ahead and write our factored binomial. I said variable, didn't I? X minus 1 to the negative 2/3 power. And what did we factor it out from? Let me show you. 4x times x minus 1 to the negative 2/3 power. I'm going to leave a space right here, and I'm going to show you why. Plus 3 times x minus 1 to the 1/3 power, and I'm going to leave a space right here. Now, let's go over here. I'm going to show a little scratch work. Not like that. Let's see. If I want to factor out 2x plus 3xy, or 3x squared y, let's show you that. 2x plus 3x squared y. And I want to factor the GCF out. What is the GCF? The GCF is 2. And you might just write it as, I said 2, didn't I? The GCF is x. And you might just write it as x times 2 plus 3xy, right? What happened? Let me show you what happened. We factored out the x are going to the 2x. What is the power of x? It's 1. How do we make this variable equal 1? Minus 1 plus 3x squared minus 1 y. 2x to the 0 power plus 3x y. Because 2 minus 1 is 1. I didn't write that 1, but there it is. What is 2 to the 0 power? Easy. X times 2 times 1 plus 3xy. Do you see what we got? That's how we got to this right here. Because x to the 0 power equals 1. 2 times 1 equals 2. What we are doing is we are taking the smallest, we are taking I can't speak. We are taking the binomial, or the greatest common factor, with the smallest exponent, and essentially making that greatest common factor with the smallest exponent equal to 1. How do you make negative 2/3? How do you make the binomial, or this part that we factored out, equal 1? Easy. We make the variable, or we make the exponent equal to 0 plus 2/3. Do you see what we just did? So now we have x minus 1 to the negative 2/3 times 4x to the x minus 1 0 power plus 3 times x minus 1. What is 1/3 plus 2/3? That's 3/3. Oh, look what we got. X minus 1 to the negative 2/3 power times 4x plus 3 times x minus 1. Hey, we can simplify that. X minus 1 to the negative 2/3 power times 4x plus 3x minus 3. Let's go a little bit further. We have x minus 1 to the negative 2/3 power times 7x minus 3. There is our factored binomial. Holy moly, what did we just do? That's crazy, huh? This isn't something you would see a lot in algebra. They're introducing it now. I don't know why they're introducing it now, but this is something you see in calculus a lot. I don't recall seeing this in algebra, in many algebra books. Then maybe some algebra books do. I don't know. I don't know every algebra book. I don't have a college level teaching either. I'm self-taught. So maybe I'm missing something that I should have. I don't know. I'm going to erase this right here. So there's a lot of work right there, isn't it? I hope you understand what we did. We factored out the term, or the GCF, with the lowest variable, and left the GCF with the largest variable equal to 1, so that we can simplify that original term, or that original expression. Hopefully this will make sense as we do a few more of them. I really apologize for not covering these in my lesson. Maybe I should have. 3c times 2c plus 3 to the negative 1/4 power minus 5 times 2c plus 3 to the 3/4 power. What do? We factor out the GCF with the lowest variable, with the lowest exponent, or what we should say, the lowest degree. So 2c plus 3 to the negative 1/4 power times 3c minus 5 times 2c plus 3. What is 3/4 plus 1/4? And remember, we say plus 1/4 because negative 1/4 plus 1/4 equals 0. That's how we was able to factor out this and not leave any residue right there. So 3/4 plus 1/4 equals 4/4, which equals 1. Now we simplify 2c plus 3 to the negative 1/4 power times negative 7c minus 15. And you could probably simplify that a little bit further by factoring out that negative. So negative 2c plus 3 to the negative 1/4 power times 7c plus 15. It's crazy, isn't it? Number 46. See if we can fit this right here. I'll be upset if I can't. 3t times 10t plus 3 to the 1/3 power plus 7 times 10t to the plus 3 to the 4/3 power. So we need to factor out the GCF with the lowest variable. Which one has it? This time it's not a negative exponent. It's a positive exponent, but it's still the less one. What is lesser? 1/3 or 4/3? 1/3 is lesser, right? So let's go ahead and factor out that 10t plus 3 to the 1/3 power times 3t plus 7 times 10t plus 3. Now 4/3. Now what did we do? Instead of adding 1/3 to this 1/3, because that would just give us 2/3, right? That wouldn't make the variable or make this term equal to 0. We subtracted 1/3 this time. So if we subtract 1/3 from 4/3, that will leave us with 3/3. Once again, we have a variable, or we have a binomial with the power of 1. Simplifying gives us 10t plus 3 to the 1/3 power times 73t plus 21. Number 47. We got 14x times x plus 2 to the negative 2/5 power plus 5 times x plus 2 to the 3/5 power. That's supposed to be a 5. I wrote a 2 instead. Okay, we're going to factor out the lowest variable, GCF. So that's x plus 2 to the negative 2/5 power. So we had to add 2/5 to that to make it equal to 0. Keep that in mind. So we got 14x plus 5 times x plus 2. What is 3/5 plus 2/5? It's 5/5. That equals 1. Now we can simplify x plus 2 to the negative 2/5 power times 19x plus 10. 48. 9y times 3y minus 13 to the 1/5 power minus 2 times 3y minus 13 to the 6/5 power. We are going to factor out the lowest variable, GCF. That's 3y minus 13 to the 1/5 power times 9y. We had to subtract that from this to get this to equal to 0. So we're going to subtract 1/5 from this part of the GCF. That's going to 6/5 minus 1/5. That's going to give us 5/5. That's going to let this equal to 1. So we can simplify now. 3y minus 13 to the 1/5 power times 3y plus 26. So you see what's going on. It seems tricky at first because we're looking at numbers. We're not used to seeing rational square roots. This is our first time actually utilizing this since learning this way back in section 1.2, I believe it was. Number 49. We have 5z, the letter z, times 2z minus 9 to the negative 3 halves. Is that what that says? Yeah, 3 halves. Plus 11 times 2z minus 9 to the negative 1 half. Oh, look what we got here. Now we have two negative numbers, or two negative exponents. How do we know which one's the smaller one? Do not be tricked. It's not the smaller number right here, 1 half, because we normally think between 3 halves and 1 half. Oh, 1 half is smaller. No. What's less than negative 1 half? Negative 3 halves. So remember that. Don't let that trip you up. That will trip you really easily. So let's go ahead and factor out a negative 3 halves part of a GCF. 2z minus 9 to the negative 3 halves times 5z plus 11 times 2z minus 9. Now we had to add 3 halves to this to make this equal to 0. So if we add 3 halves to 1 half, that gives us 1. Notice how every time we end up with 1 with one of these. Pretty cool, huh? We can simplify to 2z minus 9 to the negative 3 halves times 27z minus 99. Number 50. 6d times 2d plus 3 to the negative 1/6 power plus 5 times 2d plus 3 to the 5/6 power. We'll factor out a lowest exponential GCF. 2d plus 3 to the negative 1/6 power times 6d plus 5 times 2d plus 3. And we simplify as 2d plus 3 to the negative 1/6 power times 16d plus 15. All right. We did all 50 problems. And I actually did that in one shoot. I thought I was going to take a break in between. So I am not going to do the other ones. So let me show you. So this is all we did. We did number 4 all the way to number 50. I clicked and I can't get that click to go away. And so there are some more problems over here. Some real world applications and some extensions. So yeah, they're just a little bit more difficult problems, which I'm not really going to. Look at this one. It's all surrounded by a negative exponent. That's fun. It's 2,401. Yeah, we're not gonna do these. I'm okay for now. Unless somebody really asks for them. If somebody does, then I'll go back and make a short video and just do the rest of these maybe. That's all we're gonna do with this. We are not going to do those other extension ones. I don't know if this video is going to come out before lesson 1 of chapter 4, which will be rational expressions. I've already got the script written out. I've already got it recorded. I don't know if I'm going to push this one first, though. Maybe I will. This will be an easy render. Anyway, I hope you enjoyed this. Let me know if you like these. I'll try to keep these up. These are really long format videos. I hope these things are appreciated, because it really takes a lot of you to sit down for an hour and a half and do nothing but math problems on this little math board I have right here. This little thingy right here. This thing can be hard to deal with sometimes. Anyway, I'm rambling. I hope you enjoyed this. Leave a like, subscribe, and leave some comments. Let me know what you think. Let me know if you saw any mistakes that I missed, because chances are there are probably a few. Alright. I hope you all enjoyed. See y'all later.